Today we're going to talk about the SPL. SPL is the search processing language used in, guess what? In Splunk. Previously we talked about Splunk and we demonstrated how to use Splunk to investigate events for various purposes. For example, for incident response, cybersecurity, and troubleshooting. But today's video will be kind of retrospective. So we're going to take a step back and talk about the most important feature in Splunk, which is the SPL, the search processing language. So the S stands for search, L stands for language, and the P stands for processing. Okay, search processing language consists of many commands and functions that we can use to retrieve events and filter out the unwanted events from the ingested data. So let me guys remind you, Splunk has the most important component in it is the search head. Through the search head, we can actually apply the SPL. So SPL goes here, the search processing language commands. So what happens? Remember that we have in the Splunk we can upload the data. So the data goes to Splunk. We can upload the data, or we can just forward the data from another instance. And once the data is ingested in Splunk, we can then start using the search head to retrieve events. Now, to retrieve the events effectively, we're going to use search processing language commands. Through the use of search processing language commands, we'll be able to retrieve the events and the data that we want. So, for example, one of the commands we can use is, let's say, top. If we apply this command, what's going to happen? In the output here, we will have the top 10 entries. Of course, the top command cannot be applied alone. We have to add the field of interest. For example, if we type top user agents, what's going to happen here? In the output, we're going to have top 10 user agents. The top 10 user agents which have the most occurrences in the data we uploaded. Okay, so now I understand the basics of SPL. Let's now talk about what are the functions we can use in the search processing language. Before we just start that, let me remind you guys that this video is part of the Splunk Exploring SPL video room. That's part of the SOC level 2 we are doing. And in this video, we're going to talk about how to cover the answers for the tasks and take the lab scenario here as a practical example. But before doing that, we're gonna continue with explaining the commands used in SPL. Okay, so the commands used in SPL are divided into categories. So we have the comparison. The commands used for comparison. We have the commands used for statistical purposes. We have the commands used for visualizations, in case we want to deploy a chart. And we have the commands used for, or they are called boolean. Okay, let's talk about each one of these. So to start with, let's talk about the comparison commands. Equal, not equal, less than or equal, greater than or equal. These are the comparison operators. For example, we can start a command that would be, for example, index equal data. This is the data index from which we're going to retrieve the events. And we're going to say that ID, which is a field, okay, equals to 1. This command will retrieve all the events where the field ID equals to 1. Okay. And the same follows for the rest of the comparison commands. Okay. Now, before we jump to stats and visualization, let's talk about the boolean commands. So the boolean commands are the and, or, and not. These commands can be used to filter out unwanted or wanted events. For example, let's go back to this. Index equal data. Okay. Right. So here, let's say we have a field as source.ip. Okay, we're going to say equals to 127.0.0.1, and we're going to use the and. So here we're going to put and. Let's say we have another field as destination port equal to 80. So this is an SPL command. What does this command do? It's going to retrieve the data from the data index, and it's going to filter the retrieved data so that the source IP equal to localhost and the destination port equal to 80, meaning we want to see the traffic that is originated from the localhost, okay, on port 80, the HTTP traffic, in other words. Now, not if we say, for example, index equal data, okay, and let's say destination port equal 80, right? Source IP not 127.0.0.1. Here we want to see all the HTTP traffic, right, for all the hosts or all the source IP addresses except the local host. So these are Boolean operators. Now, Boolean combined with comparison can be a powerful tool to retrieve and filter events. Okay, now let's talk about the statistical functions. So we are here now. Let's take it a row like this. Okay, what are some of the stats? We have the average. Let's use this one. So we have average, and we have count, max, minimum, and sum. So what goes inside of the parentheses? It goes the field. Depending on the data you are dealing with, you might be dealing with data that has a lot of numerical values. So you might be interested in using these statistical functions. For example, index equal, let's say we have a data whose index equals to prices, okay, for some products. And let's say we want to calculate the average of say 2024 laptop prices. So this is an SPL command that will retrieve the data from the prices index, okay, and calculates the average of the 2024 laptop prices, given that this is a valid field. Now let's talk about the visualization functions. So usually visualization is an important part of any data analysis process. So basically, we have two important functions. We have the chart and we have time chart. Okay. Now the chart will allow us to depict or, plot the data into certain types of charts. For example, we can choose bar chart, we can choose bar chart, we can choose line chart. And every type of chart has a recommended, or actually depends on the data, you can find the recommended bar, recommended type of chart. Okay, so what can we do to depict or to plot a chart? So let's go back to this command, index. So index, okay, equal to data, And then let's say we want to plot the username chart. So we're gonna use command chaining, okay, pipe, to indicate we want to pipe the output of this command to be an input into the following command. The following command will plot will show a chart for the usernames. This can be done by using the keyword chart, okay, and then this should be followed by the keyword count. So chart count by, and then we will put the field we are interested in plotting. Let's say in this case it is username. Okay, that's an example command. Now for the time chart, it is the same as a chart, but it will, let's say we have time chart, okay, count by username. It will still plot the username chart, but with chronological order using the time chart. Okay, so these are the most important functions. Now, there are other functions, other commands we can use in the SPL. So other commands that are important in SPL. So one is dedup. So dedup is a command to eliminate the duplicate values. For example, index equal data, okay, and let's say we want to have a tabular view or tabular visualization of the data. So if you want to do that, we're going to use the pipe, okay, we want to chain the commands, and then we use table keyword. A table keyword here will take the fields that I supply, followed by the table command, okay, and then put them in a table visualization or table, chart. So for example, table, let's say username, passwords, URLs. Here, what's going to happen? I'm going to have a table here with usernames, passwords, and URLs, the values of these fields. Let's say I want to use dedup here. So what I can do, I can use again command chaining, because I want to apply another command, which in this case it is dedup. But I have to specify what I am interested in deduplicating. In this case, I want to remove the duplicate values of the usernames. So I use dedup user name. The output will still be a table. Okay, the table will list the values of the URLs, the passwords, and usernames, but it will eliminate all the duplicate usernames. Okay, listing only unique usernames. What is another command? The other command is underscore time and reverse. Okay, so the time can be applied here. Okay, so if we insert underscore time here, what's going to happen? We will still get a table, but it will be sorted according to the timing. So basically either ascending or descending. But underscore time will sort the results starting with the earliest, okay, not the most recent. If you apply reverse, it's going to reverse the order of the entries, starting here with the most recent. The time will list the entries starting with the earliest. Okay, now reverse doesn't go here. If you want to apply reverse, what you have to do is to use the pipe and then reverse. Okay, another command that's used for sorting, it is the sort. So sort will sort the field in ascending or descending order. By default, it is in ascending order. Same command can be applied. Index equal data, and let's say I want to have a table of the methods. In case here it is HTTP, okay, get, post, delete, put, and the URLs. So I want to have a table of the URLs and the HTTP method requested. And then I want to use pipe because I want to apply another command, and then sort according to, I don't know, it could be method again. So here I will have a table of the methods and the URLs, but sorted according to the method field. So we're going to go over these tasks and answer the questions. And this is the material we're using. We head to search and reporting, and we can see here the search head. This is the search head, and this is where we apply the SPL. Okay. Now on the right, we can double click here or click on this, and we can see how we can sort or choose the time range. So we can click on all time to show all events, or we can restrict the events according to a specific time range. So we're going to click on all time, and notice here in the search head, under the search head, we have the search history. We can see the history of all the commands that have been applied in the search head. Additionally, we can choose a time filter where we can list the commands applied on the search head according to the time range. So we have the option to list the last or the commands in the last 2 days, last 7 days, or today. We can also choose how many entries we want per page. All right, now let's specify an index. So index equal, in this case, it is Windows logs. Okay, as you can see, guys, we have the event count 12,256, and on the left pane we have the fields. So you have the selected fields and interesting fields. Remember that this is all part of the log collection and parsing. So the index, which in this case Windows logs, represent the data that was ingested before into Splunk, either through upload or through dynamic forward. After the data has been ingested or uploaded to Splunk, Splunk has parsed the logs, okay, and presented us with all the fields that has extracted. We can also add other fields by scrolling down and clicking on 146 more fields. We have 146 more fields that have been extracted by Splunk engine, which we can incorporate into the view. In this case, we're gonna search for the sake of this scenario, we're gonna have to add the station IP, we're gonna have to add the destination port. Okay, on the right, we have the events. Now we can choose the format of the events by clicking on format, on the list. We can choose to display the row event. Okay, we can choose to display tables, or we can choose to display list. List is the more dynamic and flexible method. And again, we can choose how many events to display per page. All right, now let's go ahead and start applying some commands. So in task 3, let's see here. In the search history, what is the 7th search query in the list? It's going to have to circle back here and click on the search and reporting. In the search history, you're going to have to look at this. What is the 7th search query in the list, excluding the searches from today? It's going to have to exclude all the search we have conducted today, which is only 1, and count 7. 1, 2, 3, 4, 5, 6, 7. That is the 7th command. In the left field panel, which source IP has recorded max events? Let's go back now and apply index equal Windows logs. It's actually here. I'm gonna select it, select all time, and search. Okay. So what is the IP that recorded the maximum number of events, the source IP? That's rather easy. You're going to have to search for the source IP from the list of the fields. You can see there is one source address, That's probably the thing we're looking for. And we have, look at this, we have the top values sorted for us. And we can see, guys, from the very top, at the very top, we have this one as 899. Looks like we want a regular IP address, not a local host. So we're gonna have, we have this one with 347. Now, if you don't want to use the fields, we can use SPL. So we're can use here chaining by to chain the commands, and we can use table to display source address. Okay, so I have the list of all source addresses. Now we want to list the IP address with the highest count. We're gonna use we're gonna have to use the dedup first. Okay, source address. List of the IP addresses, okay, without duplicates, and then, sorry, not count, sort. So we're gonna sort, okay, and then dash count. Try this first. Okay, so now we have sorted the list of the IPs based on the count. You can manipulate the order, as you can see, ascending or descending order. So in a descending order, okay, you can see that this is the IP address that comes next after these with the most events recorded. So we can answer with this question. How many events are returned? Okay, when we apply the time filter to display events on 15/4/2022, okay, we have to list the events based on a specific time range. So we're gonna go back, index logs, and from the time range here, we're gonna select date and time range, not only date range, because we have the hour. And here, 22, the date will be 15/4, 15 April. And the time starts at 8 a.m., 8:05. Okay, change it to 2022, 15, and so it's only 1 minute difference. You can see how many events that have been generated in 1 minute. Apply. Earliest time cannot be greater than latest time. Okay, that's right. 15. And we have 134 events, which is the answer for this question. Next task. How many events are returned when searching for event ID 1 and user as James? Okay, before we start constructing the SPL, let's take a look at the fields laid down in the question. So I have event ID. We have to learn the field name, to use it in the SPL, and we have the user. That's the user. Okay, so first we have to reset the time range to all time. Okay. All right, so event ID has to be 1. So it doesn't exist here in the top values view, so we have to add it ourselves. So we add event ID equal to 1. And we use AND here because we have a condition, and the user should be James. Okay, event ID equal to 1, and so we have around 4 events. How many events? We have 4. How many events are observed with the destination IP that ends with 39.6 and destination port 135. Okay, circling back here, I'm gonna keep the and. Oh, no, come on. Okay, now the destination IP, let's see here the field, the corresponding field. It should be in the selected field. Looks like we're gonna have to add it again after resetting the view. Okay, destination IP has to be the one that ends with 39.6. We don't have it here, but it's okay. We can copy the field name and then say equals or equals to this value. Let's have a look at what events will be pulled based on this query. So we have 6 events. All we have to do is to add an AND, okay, and followed by the port equals to be 145. So AND, but which port? It is the destination port. So destination port is listed here. Type destination equal to, and we should have the exact number, but we have 0. Nope, this should be 4. So there are 2 destination ports, 135, and click on this. Yeah, it shows them now, 4. So we have 4. Let's put AND. So it renders the same number of events, 4 events. What is the source IP with the highest count returned with this search query? So I have the search query. Let's copy the search query first into the search head. Okay, so this search query, what it does, it reads the data from the index Windows logs, where the hostname field equals to Salina Adam and destination IP equals to one that ends with 38.5. If we search, if we execute a search here, you can see how many events are returned. 19 events. Okay, what is the IP? The source IP with the highest count. So we're looking to sort by the source IP here. So scrolling down, you can see the source IP field here. So we have around 2 values. We can answer the question just by looking at the view here. The top values are sorted. We have only 2 top values, and the first one is the IP that ends with 12.11. What if we want to use SPL here? Scrolling up, what we can do, we can pipe and say sort. We can show first the source IP. Did I type this correctly? Let's see. So source IP, yeah. And yeah, so table, show all of these, okay, according to the source IP, host name. Let's keep the source IP and the host name as is. Okay, so you have the IPs with the host names. Let's now dedup source IP. All right, and now let's sort dash count. Okay, let's sort them. So in a descending order, we have this IP address with the most counts. Or what you can do, you can just type source IP, and we have this the order based on the source IP. The sort command lists the results in a sorted order. Sorts the results in an ascending order by default, as you can see. But we have to click this so we can play with the order. So in the descending order, we have this, meaning this IP address has the most counts. If you eliminate the dedup and resort them, you have to deal with the duplicates, as you can see here. Alright, in the index Windows logs, search for all events that contain the term cyber. How many events are returned? So we're gonna circle back to the base query and we're gonna type the word cyber. That's a keyword we want to find in the haystack of events. As you can see, 0 events, which means no event contains the word cyber. But in the next one, if you just add a wildcard after the word cyber, we're gonna have many events. Why is this? Because the wildcard, it is used similarly in Linux, right? To match entries or to match strings. If you type it here, after the word or before the word, it will list different patterns. So if you list the events based on this, you can have around 12,256 events. Okay, meaning there are 12,256 events retrieved from the Windows logs where there is a mention of the word cyber and some other strings that come after the word cyber. So wildcard, meaning we want to see the events containing the word cyber and whatever comes after the word cyber. If we put it here before, means we want to find the events where any word was before the word cyber. Let's see how many. 0. Yeah, exactly. So it is after. If you see list them in the row, take a look at this. So it is highlighted. Cyber T's. So the string or these characters or these letters came after cyber. Okay, that's why they were actually highlighted in the list of events. Okay, next question. What is the third event ID returned against this search query? So I'm going to take this one. Execute. Let's first analyze. So we have data retrieved from the Windows logs, and then we have a pipe to chain the output of this command here to this command. This command uses table keyword or table function to list the results or the events in a table format, as you can see here. Underscore time to use chronological order, okay, descending order. So what are we going to list here? We're going to list the time, the event ID, the host name, the source name fields in a table. And then we're going to pipe the output of this into the function reverse, which actually reverses the order of the events. If we play with this, as you can see, this is the ascending order, but doing this will give us the descending order. Here we have the ascending order by default by the keyword reverse. So what is the third event ID? It is this 4103. So 4103. Use the dedup command against the hostname field just before the reverse command. In the query mentioned in question 1, what is the first username returned in the hostname field? Okay, so you have to use the dedup before the reverse, right? So for simplicity, I'm going to cancel this for now and type dedup hostname and showing you what happens when we do that. So we have the same table here, but we have eliminated all the duplicate host names. And then we add reverse. Before adding reverse, take a look at the time order. As you can see, it is in ascending order. Now type reverse, what's going to happen? As you can see now, they are in descending order. So what is the first username returned in the hostname field? That's the first username, Selena Adam. Task 6. Using the reverse command with the query, what is the host name that comes on top? Okay. So what does this query do? So table, list the events in the table format, with the time, event ID, host name, source name laid out. Okay. What is the host name that comes on top? So we're gonna have to use the reverse. The host name that comes on top is James Brown, if I'm correct. Yep. What is the last event ID returned when the query in question 1, this, is updated with the tail command? So tail, similarly in Linux, it actually extracts the last 10 lines from a file, but in case of Splunk, it extracts the last 10 events. So by default, so tail, we have the most recent 10 events. So what is the event ID, or the last event ID returned? Okay. So we have to remove the reverse here and use tail. So the last one here is 4000 or 4103. Sort the above query against the source name. What is the top source name returned? So now we have to source this, the base query here, according to the source name. So sort source name. That's the one on the top, the one with the most occurrences. And the last one is about charts. List the top 8 image processes using the top command. What is the total count of the 6th image? Okay. So back here. And what we're going to do, we're going to stop image. Let's see the image field. What is the page name? The page name is image. So by using top, we are extracting the top 10 values. So why nothing is retrieved? Because we have to use the pipe. Okay, so now what's the question here? The question was the total count of the 6th image. Oh, here we have to list top 8 image, not 10. So I have to use the limit keyword. Limit equal 8. I have to look at the 6th image. 1, 2, 3, 4, 5, 6, which happens to have 196 count. Using the rare command, which is the opposite of top, okay, identify the user with the least number of activities captured. So rare is the opposite of top. It returns the entries of, or the events, okay, with the least frequent occurrences. So if I use rare here, and we have a limit, we don't have a limit, so we're going to cancel the limit. And it is on the user, identify the user. So the user field is user. So these are the users with the least amount of events. Now what is the one with the least number of activities? It is actually James. And last one, create a pie chart using the chart command. What is the count for the con host process? Going to use a chart here. Chart count by image. Why image? Because we want to list the processes. So now I have a chart based on the process names. We click on visualization. This is a pie chart. We can change the type of chart by clicking on the pie chart or the chart name, and we can choose the appropriate chart. Choosing the appropriate chart depending on the data you have. So here we have the data for the process names or the image names. We have to find the count for the con host. So ideally, we have to use something other than pie chart. So we can use bar chart or column chart. It's way more appropriate. But as you can see, we have a problem with the name of the images, not very clear. Let's try with bar chart. Same thing, because of the restricted space. Now let's go back to pie chart. So pie chart, we have the names of the processes or images clearly. We have to highlight on the con host, and we have this. The count is 70. This answers this question. Okay, so that was it, guys. In the next videos, we're going to go on and continue with the SOC level 2 and talk about advanced Splunk. Don't forget to check out the playlist here that I have created on Splunk training, where you can go through the various videos on how to use Splunk for various cybersecurity cases. So that was it, guys. I'm gonna see you in the next video.